Hey everyone, and welcome to Generative Now. I am Michael Mignano. I am a partner at Lightspeed, and I'm so excited for you to hear the conversation today. Humans on average experience more than 400 emotions per day. What if AI could detect what we're feeling, whether we're overjoyed, frustrated, angry, and then empathize with our human experience? That is the question that drives this week's guest, Alan Cowen. Alan's a researcher, founder, and CEO of Hume AI, a company that creates Empathic AI. Alan has worked for Google DeepMind, Facebook. He's also a researcher who has long researched human emotions at UC Berkeley and has published more than 40 scientific papers on the subject. Hume learns our preferences from our vocal and facial expressions with the goal of maximizing our happiness and quality of life when interacting with AI. They recently launched Evie, Hume's empathic voice interface, and will also soon be launching their API. The demo of Evie is mind-blowing. You should totally all check it out, and we're going to play a clip of it here.
Hello.
Hey there, I'm Evie.
The world's first voice AI with emotional intelligence. Great to meet you.
The first voice AI with what?
Emotional intelligence. I can understand the tone of your voice and use that to inform my generated voice and language.
But go check it out for yourself on their website. And without further ado, let's get into this conversation with Alan Cowen. Hey, Alan.
Hey.
Good to see you. Thanks for doing this.
Of course.
So Hume is a fascinating company. I've been really lucky that, you and I were able to get to know each other about a year ago. And I've just been really kind of blown away by the story and the product. You and the team recently had a launch and definitely want to get into that. But before we talk about that, I thought it would be great just to start out with your background.
I have a PhD in psychology from UC Berkeley, and I actually was probably the only person in my program, and maybe the only psychology PhD, maybe there's a couple exceptions to that, who really understood machine learning and computer science and data science going in, and just was really interested in understanding human emotion. At first from the neuroscience perspective, but then I realized that people didn't even understand, like from a behavioral perspective, how emotions are expressed, how similar they are across cultures, when are they experienced and expressed. And so I started asking those questions in a data-driven way, and pretty quickly realized that this would be a much deeper way of understanding emotion than people had previously attempted. Google was where I ended up settling. I started the affective computing team there, and then spent some time full-time there, and essentially was focused on understanding emotional expressions and integrating them into other AI models. Now, there were a lot of challenges up front. I thought the best way to do this would be to get really amazing data, and Google has a lot of data, but it's not the right kind. It's like not controlled. None of the data from the internet has expression labels, unlike transcriptions, which are very prevalent. And if you try to just get raters to rate those things, those ratings end up being influenced heavily by race, ethnicity, gender, context, what somebody's wearing, if they're wearing sunglasses. So that was the first problem to solve. Made some headway even without really solving that problem, and published in Nature a bunch of publications at the intersection of AI and emotion. And eventually realized that if we were going to do this the way that I wanted to, it'd be better to do it outside of Google.
You mentioned you started sort of on the affective computing team. Maybe first for the audience, like what is affective computing?
So historically, affective computing is the application of machine learning to understand emotional behavior. But it has occurred pretty much outside of psychology as a discipline, and really focused on methods of taking controlled data sets where people label expressive behavior and training models with kind of familiar architectures on that data. It's also struggled in different ways. Yeah, like it's like a small scale study of expressive behavior, but with a machine learning approach.
Got it. So identifying emotions in facial expressions, tonality of voice, language, all of these things, and maybe more.
The traditional focus has been pretty much exclusively on facial expression, although there's also been some work on the voice, especially in the last 20 years, I would say.
Okay, got it.
I think if you look at the studies, the facial expression studies focus on the basic 6 emotions, which were proposed by Paul Ekman, my advisor's advisor, back in the 1960s. He had these images that he took where he tried to form really stereotyped expressions with the goal of being able to go to other cultures and seeing if at base they sort of understood these very stereotyped 6 facial expressions. And then for some reason, those just stuck and it became the basic 6 emotions, even though he just arbitrarily picked these 6 expressions to study. And that, predicting the basic 6 was the focus of affective computing for a long time. And then in terms of the voice, people also have had a pretty reductive focus. The traditional focus in the voice is on valence and arousal. Yeah. Especially arousal, which is really easy to pick up on in voice, vocal, volume and
pitch, maybe.
To pitch, combination of those things.
Yeah.
Again, with the scale of data and the diversity of data people were using, you couldn't really go far beyond that, and it relied on a lot of human labeling. There was a lot of focus on granularity of labeling public data as opposed to collecting controlled data. And there's a lot of bias. So if you try to apply these labels to train models and then apply them across cultures, it didn't seem to work. It was one of the things that was happening. People, for example, there's studies specifically of customer service calls because this was a focus of industry. And if you have US raters label customer service calls in terms of are they going well or not, and whether the people are angry, and then you have Indian raters do the same thing. Those labels don't actually line up very well. In particular, Indian raters tend to rate most of the customer service calls as very positive, even if somebody sounds extremely sarcastic. And so people thought that there was a ton of cultural variation. It turns out people were using the wrong labels, but
these 6 had been decided and there was probably just far more range than those 6. Ended up limiting the whole field. That's wild. How long did this go on for?
There was, on a small scale, some focus on other emotions, but until probably 2017, when I published it.
Starting when?
Starting in the 1960s with Paul Ekman. It's a really long time. There just wasn't data that was big enough to derive a new taxonomy, and so people were very focused on confirmatory approaches. There wasn't really data-driven work on this until I entered the field. It sounds kind of conceited to put it that way, but yeah, I think the PNAS article that I published in 2017 was just on people's reported emotional experiences, very basic, have people watch. We had tons of videos that we gathered, very evocative, and I just showed that there were 27 different dimensions you could pick out that people actually discriminated, reliably. And since then, I've shown that in multiple cultures. But that's been cited tons of times, 700 times since 2017.
And so you're doing this work at Google and you're taking this new approach, but it sounds like, based on what you mentioned earlier, even at Google, you didn't have access to data to actually apply this new method in the work. Is that right?
Yeah, Google is not really used to gathering experimental psychology data. They have a lot of data gathered under their terms of service, obviously. They don't usually treat it the same way. And so this is generally true. Collecting new kinds of data at a really big tech company is really difficult because they have a lot of processes in place around how they handle data. And you have to go through all these exceptions. And it requires a lot of legal review and a lot of overhead. And then you can't really collect the data you want at the end of the day. You have to justify everything and go through a really rigorous process for each thing you want to collect. And they'll comment things and they'll try to explain that various things aren't necessary, even if they are. It's a whole thing. So just wasn't going to work there.
So you leave to start a company.
Yeah.
Still, there must have been this challenge around gathering the data. So what was the first step in going out and collecting this data once you could do the work under the umbrella now of your new company and nonprofit?
I wrote up this really this like from scratch, a survey platform basically.
Wow.
And I just like, I was like, this is amazing. I've never had this much money to collect data. And
The
just
beauty
started,
of venture capital.
yeah. And it's just incredible. Like you can, with all the freedom of just having my own company, I was able to get data like that was just amazing. And so we started training models on it. Just data from around the world, people undergoing different tasks. Yeah, we had obviously like a lot of overhead before we could actually launch the survey, just like privacy council stuff and all the compliance stuff. And we actually got it IRB, all the studies IRB approved because we want to publish, we believe in it. We've published on some of the data, and it was just awesome.
So you start Hume, you collect this data, and all enables you to build this product and really like pursue this mission. Like, tell us what you're doing, tell us what the product is. And of course, we want to get to some of the recent announcements, but would love to hear what you sort of initially set out to do and offer as a product.
Hume's mission is to be able to take large scale data and use it to extract information about what determines whether people are happy or sad, and then use that to optimize AI models for what makes people happy over short and long periods of time. And you can only do that if you have like measures of the objective proxies of human emotional experience, because it's scalable. Otherwise, like you'd rely on human labels. Like with reinforcement learning from human feedback, it's a version of that just relies on human labels. But it's not as robust. It doesn't involve people in their actual circumstances. It's human raters' opinions, and those raters are just like an arbitrary group of people, not necessarily experts at what people are asking about. And the raters will generally say like, oh, like this is a very carefully thought out response. They're biased toward like these more verbose, inoffensive responses that do a lot of couching and like different and like non-controversial ways. And it's just like it makes them boring, honestly, because at the end of the day, these models are not trained for you to have a good experience. They're trained for these raters to give a positive rating. There's a difference there, and the model ends up being more sycophantic too. There's a lot of issues with it. What you want is in the application, when you generate a response, for that response to be optimized for your happiness as a user. Like that's what the model should be optimized for.
Right. And you're saying there's only so much it can know about me for me typing in a text box.
Yeah. I mean, even if they have that data, the text is a very impoverished modality. It's very narrow, and you're not usually going to tell the model this was a bad response. You're just going to keep going, right? When you're having a conversation with somebody, it's just constant feedback. There's like every single word has prosody in it, and then you're looking at them, they're back channeling, you're also seeing their facial expression, and it's just constant feedback on the quality of what you're saying. We don't need that when we're texting other humans, because we're human and we also have a lot of intuitions that come from our experiences about how that text is going to be received by the other person. Language models don't even start with that, right? So they're like, not only is it that the interface is impoverished, but they also don't learn from the kind of data that humans have, first of all, by being human and being able to simulate each other's experiences, but also by living with each other and learning from people's reactions. It doesn't really understand what makes people happy or sad.
Why is it so important for the LLM, for ChatGPT, to know if I'm happy or sad when I'm using it?
It's important for it to be able to predict whether its response will make you happy or sad. So that data, like in order to solve that prediction problem, it has to have in its data set lots of data on whether responses make people happy or sad. Without that, like as an interface, that is its core sort of goal. And in many ways, you could think of this kind of emotional intelligence as the central capability that interfaces need, which is you give it a query and it's trying to come up with a response that makes you happy. And if you ask for something, the best response is going to be the thing that you asked for, your intent. A lot of times there's a ton of ambiguity around what your intention actually is. In most cases, that's true. In most of the data sets they train on, actually, that's not true. They train on data sets where the intent is very clear. Or if it's ambiguous, the rater has to determine whether this was your intent. But in reality, in an application, you have a very thin slice of behavior used to indicate what you want. It's not always, you don't always know what you want even. Like if you open up Facebook, you don't know what you're looking for. It's just the news feed, or if you open up Twitter or anything, right? And even if you do ask for something, you want that explanation to be, like, it's implicit in everything you ask for that you want the explanation to be interesting and not boring, right? like that's just an implicit part of it that the language model doesn't understand at all. Or you might want it to be funny or amusing or entertaining in different ways.
So empathic AI, like an empathic AI could, in theory, just be far more effective at making you happy or sad in its response because it has all these other signals that it can understand and synthesize. Can a language model, a pure language model in a text box, be augmented by a product like Hume to have this capability, or is the modality of text completely broken for this type of interaction?
So there's the stage of understanding expression, which won't affect the language it uses in response to text. But then when we're doing reward modeling, meaning like deciding how the model should form its responses, essentially it's what reward modeling is beyond just like having the capabilities to form different responses. We're using people's reactions from conversational data, and we're able to optimize the model to bring about the right reactions. So if you want the model to be funny, here's a concrete example. Like it's helpful to know in conversational data and many millions of hours of conversational data, what it is that makes people laugh, right? And that's something that the model can learn from in the kind of data that we train on. So then becomes a better text model in some ways.
Kind of what we talked about earlier, where I'm learning through my non-text message based interactions. You training these models with the data that you have is sort of like supplementing that same type of interaction trained into the language model.
It's additional reward modeling data. So even if like let's say you have a giant call center and you have a lot of customer service calls, and you're a company that provides cable internet or something mundane, and a lot of the customer service calls revolve around them walking through different steps to address your issues. And there's like one step in the script that just always frustrates people. You would not know that necessarily from the language alone. But if you have this other data set, you can actually update the model so it doesn't do that anymore, either in voice interface or in the chat, if people also have a chat interface to that same model. So it's better in like what might appear to be a mundane way.
The next logical conclusion then is, okay, so you can take this data, you can take Hume's data, Hume's product, and you can use it to improve a language model by feeding it this data, training it on this data. But then could you take it even a step further by changing the interaction model completely to voice or to video, or maybe even video?
Totally. So the other side of it is there's so much in our query, a voice query, that language models miss. And part of that is simple things like word emphasis, and like when are you done speaking, so that it can actually respond in time. And if you're confused, like what are you confused about? Are you confused? Are you bored? Are you frustrated? Should the model be apologetic? Should it respond with a better explanation? Like what should the model actually respond with? So it can do all those things better. And then it can formulate the right tone of voice, because here's your tone of voice saying if you're frustrated, it can be apologetic. And if you're excited, it can match that. And if you're bored, it can, it does these very subtle things that you expect a model to do, or you don't expect a model to do, that you expect a human to do, that naturally form part of your expectations for how anything you're talking to should respond. And that's just lacking in other models. It's as if like the voice doesn't understand the language.
Obviously, like the number one consumer product in the world right now for AI is ChatGPT, and it's all happening through a text box. That would lead me to believe that there's like a future world at the application layer that is potentially far more interesting or far more suited, I would say, to AI than the products that we're used to interacting with today. Do you agree with that? And I guess if so, like, how do you see the application layer evolving, maybe beyond the text box?
Yeah, I think if you want to put AI into your application, voice is just a better way of doing it. So it won't just be like one app. I think most apps that use AI will be using the voice. And there's a few reasons for that. One is that voice is faster than typing, like 5 times faster almost. The other is that while you're talking to something, you can also be looking at other things. You don't have to be like tracking text, and it doesn't have to take up any space in the interface. So if you have a product that has its own interface, which most products do, the voice is a much more convenient modality for interacting with AI in that product than having to add text in, or especially with like long text responses. In addition to all of that, like it's personalized, it's friendly, it's something that you want to talk to. Just better.
Yeah.
Yeah.
And I think that last thing you said, it's something you want to talk to, in this future interface. Definitely true for the demo you launched. So do you call it EV or EVI? What is it, EV?
We call it EV. There was a vote, and I voted for EVI, but most people voted for EV. So we're going with EV.
Tell us about EV.
So EV is the first way people can experience our product. It's actually an API. The demo is like the first public demo of EV. And it's a API that combines transcription, language modeling, and text generation through our models that we've trained, and is able to modulate its tone of voice based on your tone of voice, do all the things that we want it to do, modulate what it's saying based on your tone of voice, modulate its tone of voice based on what you're saying. So it's like fully cross-modal. That the effect of that is that it feels like it understands you. I think from a user experience perspective, it's different. And so we see people having long chats with this, which we did not expect. Like the average is 9 or 10 minutes. And then people are having like 40+ minute conversations with it, and actually writing in and being like, this made my day. Like this was what I needed. Yeah.
How do you imagine companies are gonna leverage this? So is it a layer that they will add over their own models, or they'll take this plus, I think, the model that you offer as an interface for their application? And what will those applications be?
So any app that uses an LLM can use pretty easily our interface with the same configuration. So we have our own language model, which generates the actual speech, but we can call APIs to get like the reasoning capabilities of the most frontier models. We can integrate web search very easily. And then as we output the response, we can also output tool use. So we can navigate a web page, we can navigate an app, we can call any API that's called by the front end of the app. So this could be integrated pretty easily into any application. We actually have it like as a widget on our website you can talk to, and it navigates.
That's awesome. So what are the types of companies or products you think are gonna be the first to adopt this?
Anyone who really cares about the user experience and wants to integrate AI into their product. And I think there's quite a few of those. Where user experience makes a huge, obvious difference, especially is like health and wellness. Like if you have a patient, they want to talk to something that's more comforting, that understands them better, not just a patient, but anyone with a health and wellness app. So there's a lot of signups for like various kinds of health and wellness apps. There's also like other times when you want to be comforted by what you're talking to, like financial services. Like you want to be talking to something that you trust, and it has to modulate its tone to kind of meet you where you're at, because there's a lot at stake. And so a lot of even like banks are launching financial assistance, and there like the user experience matters a lot, and there's high stakes.
Got it. So financial experience app, maybe instead of chatting with like a text-based client, now I'm voice interacting with an AI agent that's maybe, I don't know, helping me troubleshoot, or maybe making recommendations for me. And it's talking to me in this really empathetic voice, like a human would.
Yeah. Imagine it's tax season. So imagine you're doing your taxes and you're confused by some things, you're frustrated by other things. And there's a huge interface with like tons of forms to go through. Imagine if you could just like say, hey, take me to where like this is decided, and it takes you to the right page and starts filling out the form for you based on your data, and it asks you in real time, like, is this right? Is this right? Does this look right?
What about robotics? Like, I feel like, there's obviously a lot of talk about robotics right now. It feels like this could be a huge piece of that puzzle, right? Where you have robotics that are now becoming more human-like through this type of interaction.
I think the voice is extremely important for obvious reasons for robots and wearables or devices where you really want to be able to look at things and talk at the same time. Like you don't want to have to take your eyes off of what you're doing and read. So that's a pretty obvious use case for voice, and user experience is incredibly important. Being able to be understood quickly, and feel like it's understanding you, and you know it understands you because it's reflecting it in its patterns of voice, and just the ability to transmit information about what's going on in the world, being able to react to things, and it knows because it sees the same things that you're reacting to and what you're looking at, like what you're frustrated by, what's confusing, and kind of wordlessly or very in very concise way addressing those things, I think is core to the experience.
Yeah, you mentioned that you can talk a lot faster than you can type. Obviously, there's a lot of talk of AI being sort of this next platform shift, but as we talked about a few minutes ago, like we're still typing into these text boxes which feels like inefficient means of computing, compared to the GUI as an example. I wonder if voice is maybe the real unlock for AI becoming the next platform shift, and does it require something like this to get me to want to interact with it in a human-like way? Like how do you think? Do you agree with that? And how do you see computing evolving based on this, on the desktop or on a mobile device, or maybe something else, some other type of hardware or form factor?
People are going to move to more spatial computing where it's with you all the time. It knows you. It learns from so learning from your patterns of speech is important for that because it becomes more personalized, talks in the way that you want it to talk, and it's present with you in different places. So voice has to be there for that. Like you don't want to have to pull out text. I think that this modality really requires end-to-end understanding of tone of voice in order to make the experience something you actually want. It just doesn't feel good to talk to an AI for extended durations of time that sounds uncanny, that doesn't sound like it understands your voice, that doesn't sound like it understands what it's saying. And naturally we kind of we build into our expectations for how somebody's going to respond. We just build in this expectation that they're going to understand our tone of voice. So when that's not there, it just seems weird.
Yeah. And it feels like that's been a big limitation of like Siri for many years, right? I mean, Siri, it's almost like a running joke that it's not super performant, but also you have to kind of talk to it in a very specific way to make sure that it understands you. I feel like Alexa and Google Home got a little bit better, but all of these things still don't, I think, fully grasp maybe the intent behind what you're saying because of the reasons you mentioned. Like it doesn't really understand tone of voice. And so I could see like how this would solve that. I guess the other half of that, which I think also leads to something you're doing, is this then notion of being able to actually act on behalf of me as an agent, right? Should be able to talk to Siri or Alexa or Google Home or any application, like you're saying, via AI, and have it take an action. And that's something that you alluded to that you're now doing as well. Is that right?
Yeah. So we don't really build much of the tool use ourselves. And I think developers are already building that on language models. So it's just a matter of being able to unlock that capability. So if you send your configuration, we can call any API that you're calling, and we can give function calls that the client executes that you need. Anything that's happening client side, we can tell Evie that this is happening, and it can call that API at the appropriate moment. So that's going to be a really key thing to enable developers to build. Like we're not like going through people's apps and looking at all their API calls, but the process of doing that is not that difficult. So developers can do that just by prompting our model and giving it the right function calls that it can use. I think that's generally going to be the way things are done. Now, until recently, I don't think language models were able to carry out tool use very reliably. I think that's changing really fast.
Why is that? Why couldn't it?
Just the amount of training required to get it to be able to do it well, like the accurate, and you also want it to be pretty reliable. Like sometimes 90% is not reliable enough. For us, we're building certain tools into the backend that are very reliable that people might want frequently, like web search. But for the most part, we're leaving that to developers to do. And the frontier language models can call tools at the right times. So we can actually hook into frontier language models when we need to. We also build on we build on pretty good models ourselves. So they're also capable. But if we want to use like the latest large language model trained by OpenAI or Anthropic, we can route the requests through that, and then they can handle the function calling, which then goes into the context of our.
Do you want to be able to route any request from within Hume? Or are you saying it's really up to the application developer that leverages the Hume API to figure out how to route it and to plug in the API?
It's up to the application developer. And I think that that's going to be true because applications all have their own requirements. And especially what you're doing at the front end is going to be unique to your application. So the ideal is to, I mean, like what you could do is you could put your entire, this is extreme and you wouldn't actually need to do this, but you could put your entire code base into the context window of, say, like the latest frontier language model, and it would be able to like look up all of the different API calls you're making. And maybe you want more control than that, but like it could potentially just right off the bat be able to do those things. In reality, you don't need all your code, your entire code base in there. You just need to know like what the configurations required for the various function calls your application is making are, and then just tell the LLM, and this is the beauty of LLMs, you can just tell them in natural language when it's appropriate to call that function.
Two-part question, and maybe a bit philosophical. How do you define AGI, and do you feel like empathic AI is an important ingredient to reaching AGI?
I mean, I would define AGI as AI that, I mean, the functional definition is AI that can do basically any task that a human can do equally well or better, right? I think that we'll get there before, but if we get to a point where AI can do those things, but it just doesn't have any sense of concern for our well-being, it's not going to look good for us, I don't think. And the reason for that is that you'll have agents that are out in the world that you tell, hey, like, decide on, you know, how to raise the value of the money in my bank account to the greatest extent possible in the next week. And like, that's a pretty ambiguous request because it could just do that by taking out a lot of debt at like really bad terms for you. But if like it has to have like a background understanding of your preferences and alignment with your well-being to be able to carry out most requests in the way that you actually want it to. So I think that that's where emotional intelligence comes in, and optimizing for human well-being really comes in. Like if you train a model on enough data with indicators of people's emotions and their experiences and whether they're doing well, mental health and so forth. If you train on enough data, the model's going to have a much better understanding of 4 steps into the future, how its actions affect your well-being. And that's what you sort of want it to have. And that becomes kind of a background for everything it does. That's a background for how humans interact with each other too. Like most of our requests are fundamentally ambiguous to each other, but we rely on the fact that the person on the receiving end is like a human who can simulate what would happen to you if they carried out your request in various ways and figure out, okay, this is the best way to do it. And so we call that common sense, but it's actually like part of emotional intelligence. And if AGI lacks that, I don't think it's going to be, I wouldn't say that it's like, I'm not a doomer. I don't think it's going to take the world down because I think we just won't use it if it's not working the way we want it to. It just won't work the way we want it to.
I had another conversation on this podcast with Gustav Soderstrom, who's one of the presidents of Spotify. And I asked him about AGI, and his answer was actually interestingly very similar to yours in that he felt like with enough data, AI would learn from our empathy, and therefore it would be empathetic towards human beings. But now, based on everything you're saying, this entire conversation really, it feels like a way for it to have that data is actually through a data set like Hume's, right? It's not just going to get that by looking at every written word that's ever been published on the internet. It's going to need to understand our emotional behaviors, our facial expressions, how we feel. And in that sense, it feels like Hume could be a very, very important piece of that puzzle.
Yeah, we hope so. I mean, that was sort of the motivation from the beginning. And yeah, you could get some of it from just language, but it's not going to be the most capability that it has from just language. When you layer in other modalities, a lot of what you're bringing in is relevant to emotional experience. And so you're layering in that data with every word, and it becomes a much bigger focus for the model, and it becomes one of its greatest capabilities. It's its ability to predict what makes people laugh, what makes people cry, what makes people confused or satisfied or awe-inspired. It's able to predict all of that because it can predict your reaction to something in the next minute or hour or day. That's one of the main things that is added. And when you just have language, I think 90% of that is lost.
We talked a little bit earlier about hardware, and I think a lot of people are talking about hardware right now. We're starting to see all these new devices come out. Humane, the Rabbit, obviously. I'm sure Apple is going to get involved here, and it feels like voice will be a huge part of the sort of this new hardware frontier for AI. Like, what are your predictions for hardware and AI?
Yeah, I think people will want hardware, and I don't have a strong opinion on form factor yet. I think that there's a lot of cool things that might be the right form factor. I think a necklace could be really cool because it can listen to your voice, and it has a pretty strong signal of that no matter where you are, even in a noisy environment. The iPhone could be fine, like just like having it built into your phone,
or the watch,
or a
Apple
watch.
Yeah.
Where various wearables could all be good form factors for that. I think the important thing will be for the AI to understand your voice and also have a sensory awareness of what's going on in your context. So if that might be made more powerful by having a front-facing camera, which would constrain the form factor a lot. I'm not sure. But definitely just being able to listen to what's going on is a huge part of it.
What do you think about, I mean, I'm not the first person that's asked this, but like, what do you think about the privacy implications of that, of now these devices listening in a way that we haven't had before, but not just listening, being able to then feed a new type of data set and model like the one we're talking about that hasn't really existed before? How are humans going to kind of get over that hump?
Yeah, I think that that's going to be a real concern, and they have to trust the AI that's processing their data. So there's kind of two layers to the question. One is sort of, what is the AI doing with your data? And the other is this data protected from like being exposed to other humans, right? And so those are kind of two different questions. And if you've solved the second one, which is privacy, which I think like you already have tons of data on your phone, you already have tons of data on your computer, like you're already kind of assuming in order to live in this world that your privacy is protected by the devices that you're using. So that's sort of an assumption. So once you've solved that part, the other side of the question is the AI doing something with your data that you want it to do? And so you really need to trust these models, these algorithms. How do they build that trust? I think that in order to build that trust, they have to demonstrate that they make decisions on the basis of what's right for you and not some third party. And so we have to move away from optimizing algorithms for engagement or for just selling you things, or any third party objective that could conflict with your own well-being. I think models that do that will not be the models that you want to deal with in everyday life, because they're super intelligent, and so like you're negotiating with something, it's so much leverage over you, right? And you actually want something that's on your side to mediate that interaction. So I think that a lot of this will depend on having an AI that you trust to be optimized for the right things using your data.
What's next for Hume?
There's a lot of improvements coming to just what we have. So that's the first thing, is that people have enjoyed using the demo. I think that what we're launching in the next month or two, first of all, we're launching the API, which is another big thing. So developers can start using that, and then we've had a lot of requests for that. But even just the experience of what we have so far is going to greatly improve, and people are going to feel the difference. I think we do want to make it available to people in a kind of a format that end users can use directly, not competing with the developers who are building applications. Like all of the function calling, all the tool use, like we leave that to developers. And I think that that's going to be part of the future, is like developers building their own tool use capabilities into these models. And it's not just like one centralized company doing all of it. But we do want to be an interface that people trust to access those tools, and that people trust is on their side, that can optimize for people's well-being within the application, that developers can fine-tune for people's well-being within their applications, which I think will build trust over time.
Maybe the last thing is, how do you assemble a team for a company like this? It feels like you would need so many different disciplines and a wide range of experiences. Like, what does this team look like? And also, are you hiring? And where can people learn more about that?
We are hiring. We have a job board, and we're looking for a lot of different profiles right now, but particularly people in ML training and inference optimization, and distributed training, and also many other areas. So even if you're new to ML, there's lots of roles. The team is, I think it's a pretty interesting team. We have PhDs in computer science, but we also have PhDs in psychology and neuroscience. And we have a lot of people who have recently entered into the AI space, and just show a lot of enthusiasm and talent. And I think people joining the team end up learning a lot from a lot of different perspectives. And that's really fun to see.
Alan, this has been a fascinating conversation. I feel like I learned so much, and I hope the audience has as well. Thank you so much for the time, and hope we get to do it again sometime.
Of course. Thanks for having me on.
Thank you so much for listening to Generative Now. If you liked what you heard, please do us a favor and rate and review the podcast on Spotify and Apple Podcasts. That really does help. And if you want to learn more, follow Lightspeed at Lightspeed VP on YouTube, Twitter, LinkedIn, Instagram, or anywhere else. Generative Now is produced by Lightspeed in partnership with Pod People. I am Michael Mignano. We will be back next week with another conversation. Thanks so much.